Good day. Today I'm going to show you how to find the x-intercepts of the cubic graph. So first of all, we have to find a vector. What is a vector? The simple explanation in this case is that a vector is something whereby when we substitute it, it will give us 0 as the answer. For instance, if we substitute 2 in place of x and it gives us 0, it means 2 is a vector. So a vector is something whereby when we substitute it in place of x, it will give us 0 as the answer. So first we'll substitute 1 in place of x and see if it gives us 0. If it doesn't give us 0, we have to substitute -1 and see if it will give us 0. If it doesn't give us 0, we have to substitute 2. If 2 does not give us 0 as the answer, we have to substitute -2. But do we have to test all the numbers? We don't necessarily have to test all the numbers. We only have to test the factors of the constant. So, for instance, if it ended with a 6 instead of a 12, it means we'll have to test 1, 2, 3, and 6, since these are the factors of 6. So we have to test their positive and negative values and see which one will give us 0. So, in this particular case, it means we have to test 1, 2, 3, 4, 6, and finally 12. So, we have to test their positive and negative values. So, let's start with 1 first. Let's see if 1 is going to give us 0. So if we substitute 1 in place of x, we're going to end up having 1 cubed. So we'll have 1 cubed plus 3 into 1 squared plus 4 into 1 minus 12. So this will actually give us minus 12 as the answer. So it means that it is not a vector because it does not give us 0. What about if we test -1? If we test -1, we'll have f of -1 is equals to -1 cubed plus 3 into -1. So we'll have 3 into -1 squared minus 4 into -1 minus 12. So let's see what this will give us. So we'll get -6 as the answer. So it means -1 is also not a vector. Well, let's test 2. If we test 2, we're going to have f of 2 is equals to, so we're going to have 2 cubed plus 3 into 2 squared minus 4 into 2, so we're going to have minus 4 into 2 minus 12. So let's see what answer will this give us. So this will give us 0. So f of 2 is 0. So therefore 2 is a vector. So if 2 is a vector, the weird thing is that you'll say x minus 2 is a vector. So you will change the sign. For instance, if it was 1 that was a vector, you would say x minus 1 is a vector. Or if it was -5 that was a vector, you would say x plus 5 is a vector. So since 2 was a vector, you're going to say x minus 2 is a vector. So then we'll end up having ax squared plus bx plus c. So this is called a vector because when we divide the cubic graph by the linear graph, we will get a parabola with no remainder. That is actually why it's called a vector. So it is called a vector because when we divide the cubic graph by the linear graph, we will get a parabola with no remainder. The only problem we have is that we don't know the values of the parabola. That is why we have to write ax squared plus bx plus c. So in order to factorize the cubic graph, there are 4 different methods. There is factorizing by groupings, there is inspections, there is long divisions, and there is synthetic division. The easiest method to use is factorizing by groupings. The only problem with it is that it doesn't work everywhere. So we're going to use the synthetic division because it is the easiest and the quickest method. You will see that synthetic division looks weird, but it is the easiest and the quickest method. If you do not yet know the synthetic division, let this be part of your skill because it will save you a lot of time. So, how you use the synthetic division is that you will draw like a sideways L. It looks weird, but it is the quickest and easiest method. And what you will do next is that you'll write down the values of A, B, C, and D. So, the value of A in this case is 1, and the value of B is 3, the value of C is -4. And the value of D is -12. So you write them with their signs. So what you'll do is that you'll write down your actual vector because the actual vector is not -2. The actual one that gave us 0 was 2. It's just that when we put it here, we have to change the sign. So you'll put down your actual factor. So how you use the synthetic division is that the first thing you'll do is that you'll drop the first coefficient. So if it was a 2, you'd put down a 2 here. So you just drop down the first coefficient. The next thing you'll do is that you'll multiply these two. So 1 times 2 is 2. And you'll put the answer on top. The next thing you'll do is that you'll just add 2 and 3. So 2 plus 3 is 5. And then you repeat the process again. You'll say 5 times 2. So 5 times 2 is 10. So you'll put 10 on top. And then the next thing you'll do is that you'll add these two stuff. So 10 minus 4 is 6. And then you repeat the process again. You just say 6 times 2. 6 times 2 is 12. So you'll put the answer on top. And then you'll add this as well. So then this is going to give you 0. So how do you know you're on the right track? You know you're on the right track when it ends with a 0. If it ends with a 0, you know you're on the right track. If it doesn't end with a 0, you know there is a mistake somewhere. So just by getting a 0 at the end, the first three numbers are the values of A, B, and C. So we have found the values of A, B, and C. So this is the quickest and easiest method. So it means A is 1, B is 5, and C is 6. So let's substitute it. So from here, you're going to say, so now we have got x minus 2. And then here we're going to have, so our A is 1, so it means it's just going to be x squared. And our B is 5, so it means it's going to be 5x. And our C is 6, so it means it's just 6. So there we have it. We have found the parabolic part of it, or the quadratic part of it. So from here, we have to factorize so that we have 3 brackets. So then we're going to have negative 2 here. So let's factorize this stuff. So when you factorize this stuff, you already know it's going to be x and x. And then from here, we're going to have 3 and 2. And then the sign of the middle number always goes to the bigger number. So what does positive 3 have to multiply by to give you positive 6? It has to multiply by positive 2. So it means that side is positive 2. So positive 3 has to multiply by positive 2 to give you positive 6. So we've just found the x-intercept. So x is equals to 2, or x is equals to negative 3, or x is equals to negative 2. So we've just found the x-intercept. So the cubic graph normally has 3 x-intercepts. So when you write them in point form, it's going to be 2 is to 0, and negative 3 is to 0, and negative 2 is to 0. So this cubic graph has got 3 x-intercept. It has got 3 distinct roots. So this cubic graph has 3 x-intercept. This cubic graph has 3 distinct roots. So it's important to understand that. So roots are just your x-intercept. So if it has got 3 x-intercept, it has 3 distinct roots. Distinct meaning that they're different. So it has got 3 different x-intercepts. So it is also important to know how the graph looks like. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths, or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvements. So let's see how the graph will look like. This was our factorized form. So our x-intercept was at x is equals to 2, or x is equals to minus 3, or x is equals to negative 2. So these were our 3 x-intercepts. So we've got one at negative 2 and negative 3. So it's going to be negative 3 and negative 2. And the other one we have it at 2. So this is our x-intercept. And this was our equation. So the value of a was positive 1. So it means that a is positive. So the cubic graph has got 2 shapes. If a is positive, the cubic graph is going to be increasing overall. So it will be like this. So this is how the cubic graph would look like if a is positive. If a is negative, however, this is how the cubic graph is going to look like. So the cubic graph will look like this. So it's going to be decreasing overall. So if A is positive, the cubic graph is increasing overall. If A is negative, the cubic graph is decreasing overall. So these are the two shapes. So it will have three distinct roots, three different x-intercepts. So hence it's going to touch the x-axis 3 times. So it is important to memorize this. So in this case, because A is actually positive, this is how the graph will look like. So the graph will be increasing overall. So it starts by increasing, then it decreases, then it increases again. So let's look at a different example. So here is another example, very important. Just before we do this example, if you're interested in knowing the prices of the tutorials, the video that contains the prices and the updated contact details, just in case these ones have changed, is found at the end of this video. So how do we find the x-intercept of the cubic graph? First, we have to find the factors. So in order to find the factors, we have to test the factors of the constant. So in order to find the factor of the cubic graph, we have to test the factors of the constant. So in this case, we're just going to test 1 and 2. So we're going to test the negative and positive values. So let's start with 1. So if we substitute 1, we're going to have f of 1. So f of 1 is going to be 1 cubed minus 3 into 1 minus 2. So let's check what this is going to give us. This is going to give us negative 4. So f of 1 is not a factor. Okay, let's test f of negative 1. So this is going to be negative 1 cubed. And this is going to be minus 3 into negative 1 minus 2. And this is going to give us, this is actually going to give us 0, meaning that this is a factor. So negative 1 is a factor. So since negative 1 is a factor, you're going to say x plus 1 is a factor. So we know the linear part of it. We just need to find the parabolic part of it. So we have x squared plus, okay, so rather ax squared plus bx plus c. And we have to use the synthetic division. So we draw kind of like a sideways L. So we have to put down all the coefficients. So the coefficient of A is 1. But be careful, the coefficient of B is not negative 3. So notice x squared doesn't exist here, meaning that the coefficient of B was 0. So it was 0x squared, which caused this thing to disappear. So this is where a lot of students make mistakes when it comes to the synthetic division. So notice, when x squared doesn't exist, it means the coefficient is 0. So you'll just put on 0. And C is negative 3. And D is negative 2. So what you'll do is that you'll just put down your real factor. So negative 1 was what gave us 0, even though he has written plus 1. What worked was negative 1. So the first step, you put down your coefficient, and then you will just multiply this stuff. So when you multiply this stuff, you will get negative 1. And when you add this stuff, negative 1 plus 0 is negative 1. Then you multiply again, you will get positive 1. So you put 1 on top there. So 1 minus 3 is minus 2. And then you multiply them, you get 2. So if you put 2, you will get 2 minus 2, which is going to be 0. So every time it ends with a 0, we know we're in the right track. So we know that whatever we're left with are the values of A, B, and C. So it means that our A is 1, our B is negative 1, our C is negative 2. So let's substitute. So it means we're going to have x plus 1, and then our A is 1, so it's going to be x squared. Our B is negative 1, so it's going to be negative x. Our C is negative 2. And there we have it. So now let's factorize from here. So we're going to have x plus 1. So this is going to be x plus 1, and this side we have to factorize. So then it's going to be x and x, then it's going to be 2 and 1. The sign of the middle number always goes to the bigger number. What does negative 2 have to multiply by to give you negative 2? It has to multiply by a positive 1. So that's what we have. So from here, we'll end up having x is equals to negative 1, or x is equals to 2, or x is equals to negative 1. So matter of fact, these two are exactly the same. So what does it mean? It means that the graph only has 2 real roots. So what this means is that the graph only has 2 distinct roots. So the graph has 2 distinct roots. meaning the graph has two x-intercepts. So it's very important to know how this graph will look like. So let's find out how the graph will look like. So we have got two distinct roots or two x-intercepts. So the first one is at -1, meaning that it's going to be -1. And the second value is at 2, so somewhere there. Whenever you've got two distinct roots, one of them is going to be the turning point as well. So how do we know which one is going to be the turning point? The one that is repeating is the one that is also the turning point. So I've written it this way so that it can be easier to see. The one that is repeating is the one that will also be the turning point. So it means this one will also be the turning point. So if A is positive, then it means the graph is increasing. So the turning point will have to touch there, and it's going to be like that. So the graph will be increasing overall. So of course we do not yet know the other turning point. And if A is negative, the graph is going to be decreasing. So this will have to be the turning point. So it's going to be decreasing overall. So notice, this will still be the turning point whether the graph is increasing or decreasing. So we have to make sure the one that is the turning point is the one that is repeating. So this is the situation whenever there are two distinct roots or two x-intercepts. One of them is also the turning point, and the one that is the turning point is the one that is repeating. Alright, here is the final example. So we're given the equation of f, and we're told show that the equation has only one real root. So whenever they say show that it has only one real root, they're just saying show that it has only one x-intercept. So we just have to find our factors. So in order to find our factors, we have to substitute the factors of the constant. So in this case, it's going to be 1, 2, and 4. So we are going to test the negative and positive values of these factors. So let's find out what does f of 1 give us. So f of 1, if we substitute 1, we'll have 2 into 1 cubed plus 2 into 1 squared minus 4. So this stuff will actually give us 0, meaning that 1 is a factor. So if 1 is a factor, it means that x minus 1 is a factor. So then we're going to say ax squared plus bx plus c. So we know the linear part of it, we don't yet know the parabolic part of it. So if 1 is a factor, we will say x minus 1 is a factor, and we'll write down our quadratic equation there, our parabolic equation. So there we have it. So we know the linear part, we don't yet know the parabolic part of it. So we'll use the synthetic division. We'll draw our kind of like sideways L. So our real factor is 1, so we'll put down our real factor. And the value of A is 2, the value of B is also 2. The value of C is 0 because there is no x. Notice there is x cubed, there is x squared, but there is no x, meaning that the coefficient of x was 0, which caused it to disappear. So C is 0. What about D? D is -4. So what we'll do with the synthetic division is that we will just put down our first coefficient and then we'll multiply. So 2 times 1 is 2. So we'll just add this stuff. 2 plus 2 is 4. And then we'll multiply. 4 times 1 is 4. Then we just add this value. So this is going to give us 4. And then 4 times 1 is 4. So we add this value and this will give us 0. So as long as we got 0, we know that we're on the right track. So there are no mistakes. So it means that x minus 1, we're going to have x minus 1, and then these are the values of a, b, and c. So it means our a is 2, so we're going to have 2x squared, and our b is 4, so we're going to have 4x, and our c is -1, so we're going to have -1. So let's try to factorize this part. So now, if we try to factorize this part, it will actually give us error. You have to show them the quadratic formula. You have to show them how that when you use this quadratic formula, so we're going to have b squared minus 4ac. So we're going to have over 2a. So you have to substitute into the quadratic formula and you have to show them that it gives you error. So first of all, here we'll have x is equals to 1, or then we have to substitute into this quadratic formula. So then it will be minus b, which is 4. So it's going to be plus or minus the square root of 4 squared minus 4. Our a is 2 and our c is negative 1. So we're going to have this all over 2a. Our a is 2. So if you type this in a calculator, you'll see it will give you error. So it means there are no solutions. So it means you'll just say no solutions. So whenever it's no solution, it means that the equation has only one real root because the other ones are non-real. So notice it has got only one x-intercept. The other ones are non-real because the quadratic equation gives us error. So you literally show them the substitution into the quadratic formula and you say no solution. After you show them that the other part gives you error, you will say, therefore, f has only one real root. So you will say f has only one real root. So that is how you answer this question. You have to show them that there is only one solution and how that the quadratic part of it gives us error. So it is also very important to know how the graph looks like. So let's figure out how the graph looks like. So x has only one real root, one x-intercept, meaning that it will touch only once. It will touch the x-axis only once. So it will have one x-intercept. And if a is positive, it means that it will increase like that. So notice this other turning point is supposed to touch the x-axis. If it touched the x-axis, this was going to be factorizable, but it didn't touch the x-axis. So if it touched the x-axis, we were going to have two real roots, meaning that this was going to be a repeating bracket. If it didn't touch the x-axis, if it instead crossed the x-axis, we were going to have three distinct roots. So this was going to be factorizable and it was going to be two different brackets. So whenever there is only one x-intercept and the other part gives us error, it means it will only touch the x-axis once and the turning point will be away from the x-axis. It won't touch, neither will it cross. So this is how the graph will look like. If a was negative, however, it means that the graph would have been decreasing this way and it was going to touch the x-axis once. So notice the other part, which is the turning point, was supposed to touch, but it did not touch because it is error. So this part represents the turning point that was supposed to touch, but it did not touch. So this is how you draw the graph. And again, if the turning point touched the x-axis once, it was going to be two distinct roots. Then this was going to be similar brackets. So we're going to have two brackets that are similar because the bracket always repeats where your x-intercept is also your turning point. Or if this extended and crossed the x-axis, then we were going to have three distinct roots, meaning that this was going to be factorizable and there was going to be two brackets that don't look the same. So therefore we're going to have three different brackets, meaning three distinct roots. So this brings us to the end of the video. So if you enjoyed this video, please like the video and subscribe to my channel. Any questions you have or any videos you want me to make, please comment below. See you in the next video.